and welcome to a video tutorial on partial fractions. Now, if you remember at GCSE, they'll often pose you a question of the addition of subtractions, so 1 over an example of x plus 2 plus 2 over x minus 1. Now, of course, the first rule of addition of fractions is that you have to have a common denominator, so we cross multiply the denominators to give a common one. So 1 lot of x minus 1 all over x plus 2 times x minus 1. This is added to 2 lots of x minus 1, x plus 2 rather, sorry, wrong denominator, all over x plus 2 x minus 1. Now expand the brackets and you gain a final answer of 3x plus 3 all over the same denominator again, x plus 2 x plus 1, minus 1 rather. Now in MEI mathematics they'll ask you to go from this end value here to this, the original partial fraction. Now there's two ways of doing this. There's equating coefficients, which is what I'm going to do in this tutorial, and there's through substitution. Now equating coefficients works for all examples, whereas substitution only works for some examples. This is a type 1 because the denominators have no extra powers in them, apart from if you were to expand it and make x to the 2. If it had a squared there or inside the brackets, then there are different types, and I'll discuss that in later tutorials. Now, it's fair to say that that is equal to something, a, over x plus 2, plus something, b, all over x minus 1. That's the partial fraction form, and we just have to find the original numerators. Now, that's equal to 3x plus 3. Excuse that equal sign. So what we need to do here is when you're originally separating them, you'll do the cross multiplying once more. So we'll get a lots of x minus 1 plus b lots of x plus 2. And this is absolutely equal to 3x plus 3. I'm only accounting for the numerator in this case because the denominator doesn't change throughout. Now, the coefficient of x here is 3, which means that because the coefficients here are both 1, a plus b has to equal 3, because if you expanded those out, a and b have to equal the same coefficient as that, which is 3. The same is true in this case. Minus a plus 2b must equal 3. So you may have spotted that we have some simultaneous equations here that we can solve. So if we add them both together, we get 3b equals 6, which means b equals 2, which we know to be true from earlier. So we'll get our original result there. Now we can chuck that back into the equation, so a plus 2 equals 3. So a is equal to 1. And then we get our original fraction up the top there, which we know now is the correct answer. And that's called equating coefficients, and it works for all types, and I'll talk different types in the next tutorial. Thank you.